I figure most of you have some idea who I am, but just in case anyone doesn't, I'm Mark Erickson. I'm more or less the primary Redux maintainer. I tweet about random stuff. I pop up in every Reddit or HN thread that mentions Redux in any way, shape, or form. Um, Normally, I'm a blogger. Like text is my native medium. I spend a lot of time writing blog posts and documentation and various comments. So video is really not normally my thing. Now, this is not entirely new to me. I spend a lot of time doing shared screens with people on my team at work, but that's a little different because we can just use like Microsoft Skype for Business, hit the share screen button, and chat back and forth there. So this kind of A, one-way thing, and B, broadcasting to a much larger audience is definitely new for me. So wanted to give you a little bit of an idea of what I'm hoping to try and cover today. Um, the goal for today is to try to talk about this new action listener middleware that I've been working on for hopefully an upcoming version of Redux Toolkit. And this will probably be more of an informational session than a coding session specifically, but I do hope to get into some actual code towards the end. So big picture, uh, I'm a really big fan of talking about why does a thing exist? What kinds of problems is it trying to solve? So we'll look at some of the history of side effects management in Redux and some of the existing other APIs and libraries that are out there. Talk about what this listener middleware is and why we created it specifically, how it got into its current state, and then look at some of the actual usage examples and how it's actually implemented. And then hopefully towards the end, I'm going to try to actually put together a couple other usage examples so you can see how it works and also just how I tackle trying to work on things. Ah, I see a Lens has joined the chat. Hi, Lens. Um, as far as my setup goes, you may notice some wobbling in the video. That's because my laptop is literally on my lap and the webcam is on top of the laptop. So yes, it is kind of shaking a little bit. It's not ideal, I know. Um, and then my laptop's here. My secondary screen is over on a desk a couple of feet away. So yeah, I realize I'm going to be looking off to the side quite a bit to try to look at chat and respond to things. Um, Hopefully it won't matter as much once we get going because you'll be mostly looking at my screen. But in case you're wondering why things appear to be shaking, it's because the laptop is not perfectly stable. All right, so let's go ahead and dive into this. Oh, you know what? It also really helps if I actually shift over to my desktop so you can actually see the notes that I have here. That would be wonderful. So yeah, quick general plan. Talk about what the listener middleware is. Talk about side effects and other options. The background and how we got to the current state, and then look at some of the examples and implementation. So to start with, the best place to get an overview of what this listener middleware is right now is to go over to the Redux Toolkit repo discussions section. And it's a issue thread talking about the listener middleware specifically. And to Lens's question, I do actually have an external camera attached to my sitting on top of the laptop at the moment. I think it's a Logitech C615, if I remember right. So this section of the discussion is actually copy pasted straight out of the README for the NPM package I've published. So the overview is that the listener middleware is something that we hope to add to an upcoming version of Redux Toolkit, probably the next minor release, RTK 1.8. And the basic idea is that it's supposed to let you define callbacks that will run in response to some specific actions being dispatched, and it's intended to be a lighter weight alternative to other existing side effects libraries in the ecosystem, like sagas and observables. So a basic usage example looks like this. Right now, you would add the separate RTK incubator action listener middleware package, and you'd import this create action listener middleware function. You would write some typical Redux slice code. In this case, we've got our classic to-dos example. And somewhere in your code, you create an instance of the action listener middleware. And in order to add callbacks, the primary method that you use is a middleware.addListener function that is attached directly to the middleware instance itself. And yes, there is the example of the docs that I forgot to update that was tripping up somebody. So I'm just going to fix that right now. Because someone else in the thread was having issues with that the other day, and I should fix it now while I'm actually looking at this. Okay, looking at the revised basic example. So you call this add listener function, and you pass in an options object. And the object really takes two primary types of arguments. The first one is, how do we know when this listener callback is supposed to run? And there's a few different options that we'll see about that in a little bit. One of them is you can specify an RTK action creator function. Like in this case, we're supplying the to-do added action creator that was exported from the to-do slice. And then we provide a listener callback, and that function takes two arguments. The first is the action that we matched against, in this case, the to-do added action. And then there's a listener API object, and this is very similar to the thunk API object that is the second parameter inside of a create async thunk callback, but it has a lot more functions inside that we'll look at down the road. And then similar to thunks in general, inside of this callback, you can run any arbitrary logic that you want to. So you can do things like making some async request and fetching data from the server. You can dispatch more actions. You can get the current state from the store, but there's also some kind of workflow specific functionality built into this. For example, let's say the to-do added action gets dispatched several times in a row. Each of those dispatches is going to kick off an instance of this listener callback running. So you might have several of these running at the same time. Well, the listener API gives you a way to cancel all the other running listeners. And there's a lot of nuance around how that behaves that we'll look at later. You can also effectively pause the execution of this callback and wait for some specific action to be dispatched. And once that action is dispatched, this promise resolves, and then you can do more logic down the road. So there is some async workflow capability built into this. Okay, let me look at the chats over here. Yes, so the TypeScript stuff is set up so that as long as you're actually matching against the action object properly, the action parameter inside of the listener should be typed correctly. So that's the basic idea. You provide some way to say, I want to match against some known action that should be dispatched at some point in the future. You provide a callback that will run when that action is dispatched. And then you can run whatever kind of synchronous or asynchronous logic that you want inside of this listener. So why does this exist? I have a bit of a summary here in the README section. The Redux community has really come up with three major approaches to managing side effects over time. You've got thunks, sagas, and observables. Thunks are very simple conceptually. You pass a function into dispatch, the thunk middleware runs it, gives you dispatch and get state, and says, go do whatever logic you want to down the road. Sagas and observables are a lot more heavyweight conceptually, but they also let you do a lot more stuff. And the biggest difference between sagas and observables and thunks is that a thunk cannot respond to any kind of a dispatched action. Thunks are just, here's a function, go run some code from start to finish, the end. Whereas sagas and observables both give you a way to wait for some kind of an action to be dispatched and then run more code in response. Now, you've always been able to write some kind of a custom middleware to listen for specific actions and run code in response to that. But writing custom middleware is not a thing that most people are comfortable with. And it would really be a very bare bones kind of a thing. Like you'd have to kind of create any kind of useful functionality on top of that yourself. So the goals of this middleware are adding a more structured API that abstracts a lot of the common things you might want to do when you're writing code that runs in response to some other action type, and providing some guidelines and guardrails around that process. If you'd like some more background on some of this information, my first ever conference talk back in 2017 at React Boston was a talk on the Redux ecosystem and a lot of the different libraries and packages that had been added. And I had a whole slide set here where I went through dozens of different packages and libraries and other things that have been added and built around Redux. And I talked about some of the ways that Redux had been designed to be extensible. And one of those ways is, in fact, middleware. And I pulled up some quotes from Andrew and Dan during the original Redux design process that talked about why they invented this middleware API in the first place. And so Andrew specifically said, we came up with this middleware API because we didn't want to force Redux users to have to use a single specific approach for async behavior. Andrew's previous Flux library, Flumux, had like a promise middleware built in. The initial early versions of Redux actually had thunk behavior built in before it was extracted out to be its own separate library. And so they said, you know what, we're going to build this API that lets people plug in their own preference for async logic and behavior. And that way they can customize things how they want. Dan also said, we don't want to force Redux users to have to learn how to use RxJS or similar. So let's actually go through a couple of these slides real fast. So what is a middleware in general? Middleware wrap around the Redux stored dispatch function, and they kind of form a pipeline. When you call store.dispatch with middleware configured, you're actually running the first middleware in the pipeline. And that middleware can look at the action and say, what do I want to do with this action? I can log it, modify it, delay it, pass it onwards, anything you want. And then it can pass that action on to the next middleware, and the next middleware gets to do the same thing. And eventually, the last middleware in the chain passes the action on to the actual store, and then you have your standard reducer processing. And then the call stack unwinds, and each of these middlewares can run more logic after the rest of the processing has occurred. So your typical middleware consists of 3 nested functions. There's historical reasons why it's designed this way. Basically, it's like a functional programming equivalent of creating a new instance of a thing, basically. And really, inside that third function, which runs every time any action is dispatched, typically you would like inspect the type of the action. If it's a certain action type, run additional code in response. So a couple quick examples of this. Like if I want to count like how many times has a specific action type been dispatched, I could create a variable in the outer closure of the middleware, and every time an action's dispatched, increment the counter. And then you can actually do some goofy stuff, like you can dispatch actions that are intercepted by the middleware and are only meant to trigger behavior in the middleware, not actually cause a state update. In this particular example, I could dispatch an action that tells the middleware log out the current counts of all the actions that we've seen, or reset all those counts to 0, and the middleware can block that action from continuing and not actually let it get onto the reducers. So if we skip ahead through some of this stuff, I tracked some stats back in 2017, and it was interesting to look at some of the usage from the different side effects libraries at the time. Really, during 2016 and 2017, it seemed like there was a new Redux side effects library popping up seemingly every other day on GitHub. And if you look at the Redux ecosystem links add-ons repo that I kept track of for 2 or 3 years, there's an entire section on side effects libraries, and there were so many of them I had to group them into their own pages based on the different technical approaches that they were using. Side effects libraries based on functions, side effects libraries based on generators, based on observables, all kinds of other weird stuff. Like it was really getting ridiculous. And a guy named Francois Ward actually wrote a post in early 2016, less than a year after Redux had come out, where he talked about like, why are all these different side effects libraries popping up, and should we actually care about any of these? So it was interesting to see how by late 2017 things had kind of shaken out into really 4 different libraries that were getting commonly used. Sagas were seeing by far the most downloads, then sagas, and then observables, and Redux Loop was somewhere in the background. So let's talk a little bit about these different side effects libraries and what they actually do and the technical approaches they use before we circle back around to the actual action listener middleware. So for thunks, the best resource is the new Writing Logic with Thunks doc page that I put together a few months ago. The general idea is we write a function that receives dispatch and get state as arguments, and you pass that into the Redux store dispatch method. And as long as you have the thunk middleware configured, it will see that function, intercept it, and run it without actually letting that make it all the way to the reducers. And at that point, you can run any arbitrary logic that you want to. So thunks are really a good way to do some imperative style programming. But like I said earlier, the weakness is that they don't let you run any code in response to dispatched actions. Sagas are almost definitely the most popular side effects approach other than thunks. And sagas are based on writing generator functions, and they use a specific set of effect APIs that are exported from the Saga library. So an example of this might be this generator function right here. So function star means that it's a JavaScript generator function. And the Redux Saga library exports these effects like call, put, take every, and take latest. And you can really compare these effect functions to a Redux action creator because what they return is a plain JavaScript object that gives a description of what kind of side effect we want to happen. So in this case, when we run call api.fetchUser and we pass in one or more parameters here, what this ends up like, let's copy this out. What this ends up giving us is something like user ID. So this isn't the exact. Actually, let's see. Type call. The call function is going to return a plain JavaScript object that looks sort of kind of like this. So there's probably some kind of a string that says, what kind of side effect do we want the middleware to execute? Well, we want it to call this function. What function are we calling? API.fetchUser. What are the arguments to that function? It's this user ID. And so because we're using generators, when we do yield, the generator function pauses execution, and the Saga middleware can then go do whatever it wants. And so it's going to look at this call object. It's going to say, oh, I should call this function with this argument. And then the middleware is written so that whenever this API call returns and probably has a promise that resolves, it will wake up our function, take the response from the API, and inject that as the user value here so that the logic can continue. Sagas are a very, very powerful tool. You can do a lot of really complicated async workflows inside. I've always felt that using sagas for basic data fetching is really overkill. And as I've been looking around for examples of how people actually use sagas in practice, honestly, the vast majority of what I've seen is that they've been used for basic data fetching. Another option is Redux Observable, and this is basically a way to plug RxJS observables into your Redux store. The idea is you're supposed to define chains of observables into what they call epochs, and you then create an instance of the epoch middleware and plug it into your store, and it listens for specific actions, feeds those into the observables, and then you can do things like, again, making AJAX requests, dispatching additional actions based on the original action, checking the current Redux state, and so on. One other option that's out there is this thing called Redux Loop, and this is much less popular than either of sagas or observables. This is effectively a port of the Elm architecture over to Redux. And the idea here is that you write your reducers so that they return a combination of both the actual state that you want to update and a description of some kind of a side effect to execute based on that state. And so that really mimics how Elm, the language, works. I can see some reasons to want to try to use this, but this really didn't take off anywhere near as much as sagas or observables did. So there's been a whole big thread going on in the Redux repo for, oh my word, almost 2 years now, where we were discussing, like, does it make sense to build in some kind of a more declarative side effects approach? And a lot of this discussion has been prompted by interactions with David Khurshid, the author of X-State. David is all in on the concept of state machines, and he knows a lot about state machines. And frankly, most of his arguments about state machines are also correct. I really don't disagree with him much about that topic at all. He's also written a couple of very good posts on how, I think they were titled like Redux is half a pattern, where he points out that while you can write Redux reducers as true state machines, most Redux reducers are not written that way, because a reducer typically only cares about what the current action is. It does not look at like a state status field in the current state before it decides, do I want to handle this action or not? So that means that most Redux reducers are not actually true finite state machines. So there's been all kinds of discussion in here with people going back and forth about, like, should we add something more state machiney to Redux? Should we build sagas into RTK? All this kind of stuff. Some very good discussion in here. So, in addition to all these different threads, over 2 years ago, I filed an issue that said we should look at adding some kind of an action listener callback middleware to RTK, because we currently build in Redux thunk, but thunks don't give you a way to write code that responds to a given action. And I had seen other existing middleware out there that let you do some kind of, when this action is dispatched, run this callback type logic. So I was like, okay, we should go look at some of those examples and see about trying to build in something like this ourselves. So this is really where the idea for this action listener middleware came from in the first place. Thunks don't give you a way to respond to actions. Sagas and observables and loops do, but they're all very heavyweight in terms of bundle size and API complexity. Like, if you want to use Redux Saga, you have to know what generator functions are. You have to know how to use generator functions correctly. You have to learn a whole bunch of these API methods that are unique to Redux Saga. If you want to use Redux Observable, you have to learn the RxJS API. And while there may be some benefits to doing that, there's still a lot of, again, complexity and bundle size and overhead. So the idea here was, can we add something that is relatively simple and straightforward and solves this use case of being able to listen to additional actions? So I filed that issue back in like 2019, and there was some loose discussion for a while, and let's see where this actually gets going. Skimming. Don't say the link to the actual PR. Okay, so it looks like Lens took his first shot at trying to create some kind of middleware along these lines. Actually, Almost exactly 2 years ago, December 2019. Wonderful. That first attempt didn't seem to pan out, so Lens came back about 6 months later and took another shot at trying to put this together. And the initial approach here eventually ended up bogging down in a lot of discussion and bike shitting about how do we want this middleware to behave semantically. And there were some very interesting ideas in this earlier version of the middleware. For example, it had the idea of being able to run the middleware either before the actual action was processed by the reducers or after the action was processed by the reducers. It also had the ability to do a prevent default type behavior like you would see with a DOM event handler or a React event handler, and prevent the action from being passed down to the reducers and processed. And so there was all kinds of discussion about how do we want this to actually behave. And this went on for several months, and eventually it just kind of bogged down and wasn't actually going anywhere. So we pick up with this story back in September. I was doing some stuff at my day job, and I actually had a reason to want to add something like this. In this case, I think I was wanting to add some analytics type handling to a React Redux migration work and project that I was doing. And at the time, this was just on a branch here in the PR, and I didn't want to use a version of the code that was sitting on this branch with an entire build of Redux Toolkit because that would have limited what I could actually use. So I ended up copy pasting the entire source of this PR into my app's code base and fiddled with the types enough to make it run standalone, and then just pasted the entire thing back here into the issue just in case anyone else wanted to try out what we had at the time standalone. And because of that, I took that a few days later and I published it as a standalone NPM package, similar to how we did with RTK Query, so that people could try installing it by itself and play around with it, and we could try to iterate on the API faster without having to republish the entire toolkit package itself. So from that point, I started iterating on the API for this quite a bit. If we skim down past the copy pasted README. So in November, I went through all the different prior issues of discussion and kind of pulled out some interesting points and prior points of discussion that would be worth noting. And let's see, started publishing several different versions of this, and started getting a bunch of contributions, in particular from Faber Vitali. Hopefully, I'm getting your last name correct. Who also, by the way, is the person who implemented the upcoming RTK Query DevTools viewer for the Redux DevTools. Really excited about seeing that go live, hopefully here in the near future. So one of the big things that I added here in this early version of the middleware was a function called condition, and this was specifically based off of a tool set called Temporal. If any of you follow Sean Swix Wong on Twitter, he's been working for Temporal for the last few months. Temporal is meant to be a code-based way to write very long-running workflows, like their example of how to do monthly billing with Stripe is you write an async JavaScript function that literally looks like a while loop, and it says loosely, while sleep for 30 days, call Stripe and charge user. And so their API is designed around writing async workflows and being able to check logic and sleep the workflow until something happens in the future. And because I was thinking about like workflows and behavior, I asked Sean, okay, like, is there anything useful you've learned working on temporal that we could maybe kind of borrow as inspiration for this listener middleware? And he pointed out this function that they have called condition. So the idea is that you pass in some function that returns a Boolean, and you potentially pass in some kind of a timeout value, and it returns a promise, and you await that promise in your workflow. And that effectively sleeps your workflow until something changes that gives it a reason to continue. So it's like, okay, we could try adding something like that to this listener middleware. So I added that in version 0.2. And then I'm like, okay, if we can add that, um, is there some way to start borrowing some ideas and some API inspirations from Redux Saga? Maybe we could kind of get like a bang for the buck, like 75% coverage of what sagas are used for API wise, but maybe with like a smaller and simpler API implementation to have to remember. So if you look through the remainder of this issue, we tackled adding some new things, improving the types, making add listener take an API options object, improving some error handling. And I started thinking about, okay, like what are the things that you can do in sagas that we might want to borrow for this listener and for this listener middleware. And if you look at the Saga API docs, um, things that sagas can do. Sagas can pause and wait for a specific action in the middle of the saga. And you can do that by looking for a specific action type, uh, by looking for one of several possible action types. You can do some additional patterns on top of that. For example, take latest will kick off a new sub saga every time a specific action is dispatched, and it will actually cancel the previous running iteration when it starts the new iteration of that function. Take leading, on the other hand, runs the first instance or runs an instance of this saga when it sees an action for the first time, and then ignores any future cases where that action is dispatched until this running instance is complete. It lets you dispatch actions. It lets you run some other function, usually like an async request, and wait for that function to complete. And then it has the ability to fork off child saga instances. And this is where you can write some really powerful, almost like background thread type behavior. Start a child, cancel a child, wait for a child to complete and return a value. And yes, the implementation of sagas internally is like crazy complicated. So sagas are really powerful, and they do let you write some incredibly complex async workflows. I used sagas on my first React and Redux project back in 2016, and it was specifically a case where we had like a list of potentially thousands of individual requests that needed to be processed by the server, but they were being controlled by like a VCR style play, pause, jump around kind in the timeline kind of an interface. So the idea was we'd like send a batch of like 5 items to the server to be processed. bring those back to the client and cache the results, run the next 5, pull them back. But if the user jumped ahead in the timeline or like scrubbed the playback back and forth, we would need to cancel some of the existing requests and jump ahead and run some of the calculations that were way further in the queue. So Saga has made a lot of sense for that kind of a use case. So as I was looking at all this, I was thinking, how can we kind of get our best bang for the buck and do like 75% of what sagas can do, but can we do that while keeping the bundle size small and trying to keep the API relatively simple? So one thing that sagas can do that the listener middleware could not do originally was being able to cancel existing instances that are running and being able to kick off child jobs or tasks in some kind. And a lot of the issue here is that async await and promises in general really are not cancelable. The question of canceling promises has been discussed in hundreds of GitHub threads and TC39 standardization discussions. And there's a lot of people who are still very angry about that topic. So promises themselves really can't be canceled per se. And that's one of the reasons why sagas use generator functions, is because generators give up control so that some other function is driving the execution of the generator. Every time a generator function calls yield somewhere inside, that function is paused. And whatever other function started executing the saga can then tell it to continue execution at a later point in time, or just actually cancel it and not continue that saga or that generator function at all. So really, if you want cancellation, for the most part, you need to use generator functions or observables. And then I was also really curious, is there something we could do to add some kind of like a child job task process fork or spawn capability to the middleware? And when I started mentioning this to Lenz, he's like, look, we really don't want to make this middleware more complicated than it needs to be. We probably don't need to do this. I was like, yeah, I know. But I would rather explore that territory now and see if it's something worth pursuing, and say, no, let's drop that idea and dial this back, than to ship a version 1.0 of this middleware now and then realize down the road that we really should have added this, and enabling that capability would require major API changes. So I spent a bunch of time looking around. Yeah, pretty much. Lenz is saying I went wild on that. So I spent a bunch of time looking around, as usual, at other libraries that were trying to solve this problem in different ways, coming up with my usual list of ridiculous numbers of links to documentation and libraries and things that looked interesting. And one of the interesting things I found was a library called Ethos Softworks/job. And I looked at it, and I really liked the fact that it had a fairly small API, the fact that it had cancellation capabilities built in, the fact that it was already written in TypeScript, and the fact that it was MIT licensed. Therefore, the code is fair game to use in another library. So I copy pasted the code from that library into the listener middleware, and I put out, I think it was version 0.4. And so in 0.4, I added a take API that listeners can use to pause and wait until an action is done. Added the ability to cancel existing instances of the middle of the listeners that are running, and added the ability to use this job library to fork off child tasks in some way. So that worked. It brought the size of the library up to about 6K minified, I think. And Lens was like, okay, maybe we could do this in a simpler way, possibly using abort controller somehow. We were already using abort controller over in create async thunk, so there is some precedent for using abort controllers in this code base. So Faber, who has been doing an amazing job helping to flesh out this middleware, went in and rewrote the implementation of all the existing task and condition and cancel functions that we had built in to use abort controller instead, and we promptly dropped the use of that job API instead. So the most recent iteration that we had, ever since Lens's initial PR, we had this option called when that lets you specify, do you want to run the listeners before the action is processed by the reducers or after it's processed? And that made more sense when we had the ability to cancel the action and prevent it from being processed by later code. But ever since we dropped that capability, this when option really didn't make sense anymore. All of the other side effects middleware like sagas and observables run that code after the reducer has executed. So Faber suggested that we drop it. Lens had already suggested that we drop it. And it's like, okay, yeah, let's just rip that out. So I went in and removed that option. We did some other fixes to the error handling and some other API tweaks. So where things stand at this point, the listener middleware package is currently sitting at version 0.6, and I feel like the API has kind of mostly stabilized at this point. We'll probably make some more tweaks, and I know there's some TypeScript type related behavior that still needs to be fixed up, but I feel like the current API gives a pretty decent coverage for the kinds of things we would want to be able to do and what those APIs would actually look like. And yeah, it's been a lot easier to have this as a separate NPM package and be able to just keep publishing this separately rather than trying to do like additional Redux Toolkit alphas or something. Let's see, any interesting chat comments at the moment? Yeah, iteration on the API is actually the biggest reason to do this as a separate package, because as library maintainers, once you release an API, that API is pretty much permanent. You can theoretically remove it in a major version, but even then, you really have to be sensitive to how much of my user's code am I going to break. And just because you might be releasing a major version doesn't mean you should break a ton of user code. So we really wanted to make sure that we're happy with this API before we actually release it in Redux Toolkit itself. So on that note, let's go ahead and skim through the API docs for this. And actually, tell you what, I've already been babbling for an hour. Let's take like a 5-minute break and give me a chance to get up and stretch a little bit. And I'll be back shortly, and then we'll dive into the API and how this thing is actually used. All right, where were we? As you may have noticed, Mark talking for 2 hours is not the problem. Really, the problem is will Mark actually stop talking at some point? Okay, so let's look at the actual API stuff that we've got here. So the starting point, like so many of the other Redux Toolkit APIs, is a top-level function that creates an instance of the thing. In this case, create action listener middleware. And right now you can pass in two different options when you create the middleware. One is a so-called extra argument, and this is basically the same idea as with Redux thunk. Like maybe you have some kind of like an API service layer or something that you want to inject at the application setup time, possibly to enable testing of some kind. So like you'd like swap it out with a mock service layer in a test. So you can inject that here when you create the listener. And then you can also supply a top level global error handler that will be called if any of the listeners happen to throw some kind of an unhandled error in some way. Once you've created an instance of the listener, sorry, an instance of the middleware, you're going to want to actually add some callback listeners that will be executed at some point in the future. And you do that by calling listener middleware dot add listener and passing in a set of options. And the options currently look like this. The two main things that you can do are specify when is my listener callback supposed to run, and then you actually provide the listener callback itself. So there are currently 4 ways that you can specify when is this callback supposed to run. You can give a plain action type string like quote to-dos / to-do added. You can add an RTK action creator like the ones generated from create slice. You can add a Redux Toolkit matcher function, which are functions that take an action object and return true or false if it matches some condition. And then you can add, you can provide what I'm calling a predicate function. And a predicate is like one of those matchers where the first argument is a Redux action, but it also receives the current Redux state and the previous Redux state as arguments. And so you could use those to do more specific behavior like only run this listener if we're in a certain state or a certain piece of state changed as a result of this action. And then you provide the listener itself, which receives the action object as its first parameter and this listener API object as its second. So these are all valid ways to add a listener, either as an action type string, an action creator function, an RTK matcher function, or a predicate that looks at action, current state, previous state, and returns true. And the middleware will run these checks after every action is dispatched. So the reducer will run, the state will be updated, subscribers will be notified, and on the way back out, the middleware looks at the list of subscribed listeners and double checks each of them to say, does your condition match? If so, run the listener. There is also the option to remove a listener later on. Currently, that's a little bit limited. You can only really remove listeners based on an action type match. I don't really have a good answer for how to remove them if you supplied a matcher or a predicate to start with. Now, you can call listener middleware.add listener at any time, but most likely you're probably doing that during the initial application setup process. So that's really intended for more of a like statically adding listeners once ahead of time as the application is being created. One of the things that I really wanted to have in this middleware was the ability to dynamically add and remove listeners at runtime. And to be able to do so, even if you don't have a reference to the middleware instance itself. So I specifically wanted to do that by dispatching an action that the middleware intercepts. And it's really the exact same principle that I showed in this slide right here. When you dispatch this add listener action, the middleware is looking for that type specifically, doing some work, and then it does not pass that on to the reducer. So this is an action whose only job is to trigger behavior within the middleware itself, kind of like a single purpose event bus in a way. And so similarly, you can also remove an action at runtime using that same mechanism. This unlocks a lot of very interesting capabilities and use cases, including some that we do not necessarily recommend. Lenz strongly pointed out that this makes it possible to have a React component listen for specific actions in the Redux store. Normally, your React components are only looking at the Redux state and re-rendering when some piece of state changes via useSelector. You could actually listen to specific actions by adding a listener when the component mounts in a useEffect, and then removing it when the component unmounts. This is not necessarily something we recommend, but it is a thing you could do with this API. So you've added a listener, some action has been dispatched, and now your listener callback is running. And you want to do some work inside of that. So similar to the thunk API object that we provide in a create async thunk callback, the listener callback functions receive this listener API object as their second parameter. And it's an object because that means we can continue to add and modify the fields that are inside of it without having to completely break the API by defining a bunch of positional parameters. One of the things I've learned about API design is that using options objects instead of positional parameters gives you a lot more flexibility down the road. So as we've iterated on the design for the middleware, this listener API object has gained a lot of additional functions inside. And so I've kind of tried to group them by category for what is their intended purpose. So all of these are inside the same object. I'm just categorizing them. So first off, there's things you can do to interact with the Redux store itself. You have your standard dispatch function available. You have your standard get the current state function. And we also include a get original state method. And this specifically returns the store state as it existed when the action was dispatched before the reducers ran. And that way, if you want to do some additional comparisons inside of the listener, you can do that. If you supply that extra argument when the listener middleware instance itself was created, that is accessible here. And then there are some functions that can be used to manage the subscription of this listener definition itself. So if you call listener API.unsubscribe, that actually takes the definition of this listener and removes it from the middleware so that any more actions that it was listening for will not trigger more copies of the listener to run. If you want to re-add this listener setup later on, you can call this subscribe function to re-add it. Another thing you might want to do is cancel any existing instances of the listener that are currently running besides the one that is executing right now. So there's a function called cancel active listeners. This was originally called cancel previous, but the problem is it actually cancels all other running instances except this one. So in 0.6, we renamed that to be a little more clear. And then if you want to know, has this specific instance been canceled, there's an abort controller abort signal passed in that lets you look to see if it's been canceled or add an event listener to see if it's been canceled. So these methods give you a lot of flexibility in manipulating the behavior of the listener, and we'll look at some of those some examples of that in a little bit. From there, we also have several functions that manage conditional workflow execution. And these were inspired by a combination of the temporal workflow API and some of the functions from that jobs library. So the take method accepts another one of those predicates as an argument, plus an optional timeout, and it gives you a promise, and the promise will resolve whenever this function returns true after some action was dispatched. And it gives you back the action, the current state, and the previous state. So you could use this within one of the listeners to say, wait until some action is dispatched, and then give me that action plus the state at that time. There's a very similar function called condition, which also accepts a predicate and a timeout, but it returns a Boolean that is true if the predicate actually resolved, or false if it timed out. And that lets you write like an await condition inside of an if statement to write kind of like an asynchronous conditional logic type behavior. There's also a built-in delay function. It's the classic, sleep for n milliseconds type of a thing that we've all written ourselves, as well as a pause and wait for some promise to resolve. Now, the really interesting thing about all four of these functions is they are cancellation aware. Earlier, I said that you really can't do much with canceling promises. A promise by itself really can't be canceled. And to get true cancellation behavior, you really need to have generator functions and something driving that. All four of these methods have behavior built in so that if you were to cancel this instance of the listener while that function is waiting to resolve, it will eagerly bail out, throw an error, and reject the promise that was returned, so that while your function was paused waiting for this behavior to continue, it can be canceled. So cancellation kind of requires that this listener has to cooperate and use one of these methods to pause itself, waiting for something further to occur. And while it's paused, it can be canceled externally. And finally, we have a fork function built in that lets you kick off some kind of a small child task. And once that child task is started, you can cancel it and you can await for its result to return. I'm using Windows 10 in case you're wondering. So that's the API at the moment. You can add listeners during app setup, and at runtime, listeners receive an options object that contains a bunch of functions for dispatching, getting state, uh, subscribing and unsubscribing the listener, canceling the listener, pausing the listener, waiting for something to happen, and kicking off child tasks in some way. If you've looked at the Redux Saga API at all, you should see a lot of very obvious parallels with the things that sagas let you do. But hopefully this API is a lot smaller and simpler and easier to understand overall. So we'll skim through the docs and look at some additional usage examples real fast, and then we'll actually look at how some of this is actually implemented under the hood. So the simplest usage is some action was dispatched, run a little bit of code in response. So like when I said earlier that I was trying to add some analytics handling to my application at work, a basic example of this might be adding a listener. We want to match on one of several possible action types. Inside of my listener, I probably want to know who is the current logged in user, because maybe I want to include like a user ID or something in the analytics that I send to the server. And maybe we can also assume that each of the actions that we're listening for has some kind of additional metadata or something that we're interested in. So we can call getState to grab the current user data, and we can read some values off of the action, and then we could call whatever our analytics API is and send those back to the server. So you could implement some fairly typical run some analytics in response to an action type behavior. You could write some data fetching behavior based on this. So one of the common patterns with Redux Saga is that you want to trigger data fetching by dispatching some generic action that says like, here's the URL and here's the type of data and here's some description of the action to dispatch when the data is fetched. So you could implement some behavior where you read the description of the data to fetch, dispatch your pending action, make the request, dispatch your loaded action afterwards. Do I recommend that you use the middleware for this? No, because RTK Query does an infinitely better job of this. Please don't do this. But this is an example of the kind of thing you could do with the middleware if you wanted to. One nifty thing that you can do, so I talked about this unsubscribe API method that's built into the listener API objects. Sometimes you might want to do like a one-shot listener. Like I want to listen for the next time this action is dispatched, run some code once, and then never, ever, ever listen for that action ever again. So you could do that by calling listener API.unsubscribe inside the callback, and that would happen. The callback would get executed the first time the action is seen. You unsubscribe, and the middleware never bothers running that ever again. So getting into the more complicated side of things, you can use this to write some moderately complex async workflows. Now, the middleware is not meant to completely replace sagas or observables. Those are wonderful tools designed for very complex async workflows, and we're not trying to completely put them out of business. But honestly, based on what I've been able to do so far, I think this can mostly replace sagas and observables for a lot of the things you might have done with them previously. So let's look at a couple examples of what those workflows might look like. Here's a test that I copy pasted out of the test suite. And let's see, so condition method resolves promise when there is a timeout. So in this example, let's see. Number one, it's only going to execute the listener when we match a specific action type and some current state value matches something that we're looking for. And once this listener starts, it's actually going to pause. And the condition that we're going to wait for is only continue once the state value is now up to 3. And we're only going to wait for a maximum of 50 milliseconds. And in this case, I'm going to kick off the listener by dispatching an initial action. My test expects that the listener did immediately start to run. I verify that if I dispatch a second increment, it should not still be running. And then I'm going to pause the test for a little while, dispatch a third action, but because the listener had already continued, it should only have actually checked the state a couple different times. So the idea is use this condition API, wait for the either condition to resolve successfully or the timeout to expire, and you can build some pretty complex async behavior out of that sort of stuff. Another small example, forking off child tasks in some way. So inside of the listener, I can call listener API.fork. The fork takes a callback that gets its own little fork API object inside, including like a delay and a cancel. And then you can do whatever additional work you want in here and return some result at the end. So I could have the child task go off and do some additional complicated work. I can wait for that in the parent, and then I can get the result after the child completed its efforts. So if we go through here, there's a few more examples of some more complicated async workflows. And then we get to the question of how do you handle TypeScript behavior? So on the one hand, we've tried to get a lot of the types set up so that if you provide like an action creator or a matcher function, the type of the action parameter in the listener is correct. But on the other hand, you have to define the middleware before you can create the store. And the listeners can be added later, but the listeners are being defined separate from the store setup. And a problem that I ran into is how do we know what the correct type is for the getState functions inside the listener API? Because at that point, we don't know what the type of the state is for your application. So what I settled on was doing something very similar to what we recommend for the React Redux hooks, where out of the box, they don't know the type of the root state, but we provide some special types that let you declare pre-typed versions of, in this case, the add listener functions, so that you can create the store, infer the root state type, and then declare these specially typed versions of the add functions. And if you use those instead, all the types trickle through the rest of the behavior, And when you call listener API.getState, it's actually got the right state type. So I think this is probably the best option we're going to get good typing behavior inside the listeners themselves. Obviously, I'm just kind of rambling on here. If anyone over in the chat has questions, feel free to ask, and I will pause and try to actually answer them. A question: couldn't you set up the listeners after creating the store? You can. Part of the issue is that the add listener function is part of the middleware definition itself. And so the built-in types of listener API are already baked in by the time you call create action listener middleware right here. But we have to have this middleware instance before we can create the store. And since the types of the listener are supposed to be inferred when you pass the listener in to the add listener function, you end up getting a nasty circle involved. So using these pre-typed versions is really the best compromise I can come up with. Plus, we know this approach works because we do it for the hooks anyway. All right, so let's look at some actual code. Enough of me just babbling and looking at GitHub stuff. I'm going to briefly skim through some of the implementation so you can see what this looks like. And then let's look at some of the tests so you can see some examples of behavior. And then we'll move on to some of the actual kind of usage example type setup. So right now, the listener middleware lives in the Redux Toolkit repo. We converted it into a mono repo earlier this year, so it's under packages/action listener middleware. And the bulk of the code is really right here in index.ts. Faber has been doing a ton of work to refactor the contents of this and try and set up the handling so that each instance of the listener middleware gets its own unique cancellation and abort signal functionality. So we've got some functions being defined that allow us to create the fork method that will get passed in as listener API, the condition and the take methods that will be passed in. We've also got a function here that takes the options parameters and converts that into the internal listener entry that we actually store inside of the middleware. Internally, what we keep track of is a predicate function that we use to run to know if we should execute the listener, plus the listener itself, a unique ID just so we can keep track of things, a list of any pending instances of that, and an unsubscribe function. But the problem is that users can pass in those 4 different ways to declare how we want to match against some given action. So I really wanted to centralize that logic in one place. So I added a function here that accepts those options and figures out which one of those did the user provide: a type string, an action creator, the matcher field, or the predicate field. And I was able to reshuffle some of the logic here to kind of shave off a few bytes and shrink it down a little bit. Let's see, we've got some global error handling here that will safely report errors without causing the middleware or anything else to crash. We've got some action creators for adding and removing, plus some goofy type shenanigans. And then we've got the function that actually creates the middleware instance itself. Inside the middleware, it's a closure, and we're going to create a map that keeps track of all the listener definitions that we've been given over time. We've got some logic for adding and removing those. And then we've got the logic for actually triggering one of these listeners once an action has matched. And I'll come back to that in just a minute. Oh, hey, more people joining. Hi. Also, FYI, I do plan to try, I am recording this right. Yes, I did hit the record button earlier. Good. And I do plan to put this up on YouTube sometime in the next few days. No promises. But it should be up on YouTube eventually. So the actual body of the middleware itself is actually not all that complicated, probably because we've moved some of this stuff out to other functions. So the first thing we want to know is the current action actually a dynamic request to add a listener at runtime? If it is, we double check to see if we've got a corresponding entry already, and if not, we add the listener to the internal lookup table. Or if it's a request to remove the listener at runtime, we process that. Assuming it's not either of those, and this is any other Redux action, then we're going to handle passing the data on to the reducers and then checking to see which of these listeners actually need to be executed. So we need to get a copy of the current state as it exists before the reducer processes the action. And then we're going to forward the action onwards to the reducers. You know, as I'm looking at this, it occurs to me that this might actually be running a little more often than we want it to. Like, I don't know if we want this to be checking for the listeners to run if it's actually a thunk. Because right now, if a thunk is being dispatched and this middleware is before the thunk middleware, the action could actually be a thunk function. And I'm not sure if it really makes sense to trigger the listening code. If it's an interesting question. I may have to decide if it makes sense to limit this to only do the listener checks if it's a true action object. That's an interesting question. Also a question, why are we casting unknown? The answer is that we have no idea what the other middleware might be returning. So by default, store.dispatch returns the action object that you passed in. But any middleware can override that behavior and pass back a different return value from dispatch. So truly at this point in the code, we have no idea what this result value is. It could be a Redux action object. It could be the result of a thunk function. It could be a promise. It could be an unsubscribe callback. It could be anything else we don't know and we don't care. But once we've let the reducers process the action, at that point we just check to see, do we actually have any listener entries defined? If so, we're going to loop over all those entries. For every entry, we're going to run the predicate function, pass in action current state original state, see if it says yes, run the listener, and if so, kick off the logic that actually runs that listener callback. So let's go look at that part. This gets a little more complicated because we want to create some unique abort controller instances for every instance of the listener that gets kicked off. So we're going to create one abort controller that kind of manages cancellation for this instance as a whole. we need to create a function that is the take method that we're going to pass in, but has a reference to this unique abort controller's handling. Same for the condition function, which is really a take behavior that returns a Boolean. We need to create instances of delay, fork, and pause that can all be canceled by the same abort controller. Track the fact that we are keeping tabs on this instance of the listener. And then we're going to finally call the listener. We pass in the action object as that first parameter. And then here is where we construct that listener API. So we've created unique copies of all these functions that have an abort controller instance that is unique to this running instance of the listener. And then we also provide functions to subscribe and cancel other entries. So that's pretty much it. And then the create action listener function returns the middleware, and we attach add, remove, and add listener action as fields on the middleware instance. So there's definitely a few things going on here, but conceptually it's fairly small. We've got a lookup table of listener entries. We run the reducers. We check to see if any of the entries match the action, and if so, run them. That's it. Someone was asking earlier, like, what does the code for the Saga middleware actually look like? The answer, it's really, really complicated. Let's see. Source. Where's the middleware stuff in here? Internal. Yeah, there is a lot of really, really ridiculously complicated stuff going on inside Redux Saga. And this is actually kind of reflected in the bundle size. So right now, this middleware is about 3.5 to 3.8K minified, I think. And sagas are, I'd have to double check. It's like 8 to 10K depending on how many of the different pieces you imported. Observables are like 11 to 15K. No, minified, not yet gzipped. So for the observable middleware, the biggest question is how much of the RxJS library are you importing? The middleware itself isn't that huge, but the RxJS operators can add a lot of bundle size. So my rough estimates right now are that the listener middleware is maybe like 20 to 30% the bundle size of Redux Saga. But I think based on the API that we give you, you can probably do about 75% of the things that you could do with sagas. Another question is, how much interaction have you had with the maintainers of Redux Saga? Not much on this specific topic. So I think Matthias Brzezinski, Anderist on Twitter and GitHub, is the primary maintainer at this point. I've chatted with him for some other things. I don't think we've specifically talked about the listener middleware so much. So hopefully that gives you an idea of what this is actually doing internally. It's not all that complicated. So let's look at some of the actual tests. Let's fold everything. So I've got the tests grouped into several different categories just for being able to find where everything is. So let's see, subscription and unsubscription. So for example, there's one that says, okay, I can dynamically dispatch this add listener action at runtime, and I can verify that, yes, the listener actually gets executed based on that. We verify that you can subscribe and unsubscribe in various different scenarios. Verify that the listener API has some built-in capabilities. We've got some tests for error handling. Here's one that Faber wrote, testing the take method in the listener API. Let's see what this one looks like. Oh, pretty simple. So we create a store. We add a listener that will match the increment by amount action. And inside the listener, we're going to pause the function until the basic increment action gets dispatched. And we're going to see, do we get back the action, current state, previous state combination? And so the test is dispatch increment by amount to kick off the listener, dispatch plain increment so that the take method hits something, wait a couple ticks just to make sure the promise is resolved, and then verify that what we got was an array with the action object, the current state, and the previous state. Again, I want to give a lot of credit and thanks to Lens for doing the initial implementation of this middleware, and Faber for doing a lot of the work to flesh out the API and get all the abort controller stuff in place. So we've got some tests for handling some of the job API, and then we've got a bunch of type tests down here whose only purpose is to type check things and tell us if things are going to fail to compile at the TypeScript level. So these really aren't even supposed to run for the most part. And actually, I probably should have like a .skip on here. But the goal is to see, do the types actually work right? So for example, I've got a test down here, create a pre-typed middleware. So I can actually pass a generic arg into create middleware if I know what it is, or I can create these pre-typed add listener functions and then call those. And you can see that in here, I would expect that when I call get state, it now actually has the correct state type baked in. Okay, so it's 2:45 right now. I notionally said this was going to be 2 hours, but there's no strict time limit at the moment. I'll probably keep babbling for another 30, 45 minutes at this point, because I would like to actually try playing around with this a little bit, just so you see some actual code happening. Another question, do we use a util library for type testing? Not at the moment. We mostly just use some various helpers, that mostly ones that Lens has written. I actually copy pasted a few of those over here, I believe. So for example, there's one called expect type. So you call expect type, you pass in an actual JavaScript value, but then you assert as a generic parameter what you expect that type to be. For example, yeah, so here I would expect that when I actually get this action object, that the type of the object is a JavaScript object with a field name type, and the value of the type is a string ABCD. And if I were to change that in some way, oh no, it doesn't compile because the types are not compatible. So Lens has written a lot of utility functions for that sort of thing that are scattered throughout our code base, and I have copy pasted several of them. All right, so over here in this use cases file, I wanted to see how many of the Redux Saga effects operators can I imitate to get an idea of how much of the Saga API we can kind of replicate in some way. So let's look at a couple of these examples. Actually, the first time I ever used Redux Saga was writing a long polling loop. Let's actually look at that real fast. Where did that loop end up? Over here. So this was the first Saga code I wrote back in like early 2016 or something like that. I had an application that I was rewriting into React and Redux, and the server had a pseudo push event capability. So the server could gather up a list of events that it wanted to send out to a given client, but I didn't have the ability to use WebSockets yet. So the client had to keep asking the server, are there any events? Are there any events? And since I didn't want to keep hammering the server with API calls every couple seconds, I used an approach called long polling. The client makes the initial request. If the server does have something to send back, it just completes the HTTP response right away. Otherwise, it sleeps on the incoming request for like 30 or 45 seconds. If it has something to send out before then, it wakes up the request and completes the response. Otherwise, it might actually kind of time out the response and say, nope, I didn't have anything. And when the client finally receives that response, it makes another request. So you're probably only sending out like one request per client every 30 or 45 seconds. So when I rebuilt that client in React and Redux, sagas seemed to be a good answer for how to write that code. And especially during the early development of the client, I needed to be able to turn the polling behavior on and off. So I wrote a saga that looked for a start polling action, forked a child process that does the actual polling work, and then waits for a stop polling action to be dispatched. And when it sees that, it cancels this child task. And the body of the child task is an infinite loop that makes the API call to the server, processes whatever events the server sent back, if any, and then repeats that. So this was fairly simple, straightforward. It worked great. And I wanted to know, can I write the same kind of code using the new Action Listener middleware? And the answer is yes. So in order to replicate that behavior, I had to kind of do some dummy test code to fake making an API call to the server and being able to resolve that on demand. So the test code fakes up a poll for event function using an event emitter API to resolve the promise. And the fake behavior that we're going to do is just how many times did our server send back message A, B, or C? So here's the actual body of the listener. So we're going to wait for this event polling started function to get dispatched, or action to get dispatched. We fork off a child task that will do that infinite loop. Then the parent waits for the stopped action to be dispatched and cancels the child. So this part looks pretty similar to what the Saga was doing. So let's see what the body of this polling task looks like. Well, we've got an infinite loop. We're going to call the poll for event function, which returns a promise. But in order to make this cancellation aware, we can't just await the poll for event promise. We have to wrap it in this pause function, because that's what double checks if we've been canceled or not. Once we get back a response, we can check to see if this was one of the server messages that we were looking for. And if so, we just increment the number of messages received to say, yep, we got it. And then for the purposes of the test, I also double check to see, did this get canceled at all? So from there, I've got some test behavior that kicks off the listener, triggers a couple of those pseudo server events so we can see that yes, the child loop is actually doing something, and verifies that yep, things got updated and we actually did see the child task get canceled at some point. Over here, we got a few more specific examples of things that you can do with the Redux Saga API. So I was able to demonstrate that you can do something similar to throttling by unsubscribing the listener and then resubscribing it after a certain timeout. So that's kind of equivalent to the throttle operator. You can do a debounce or a take latest style operator by canceling any of the existing running instances of the listener and then waiting and delaying before you do any actual work. Take every is actually pretty much how this listener works already. So a separate instance of the listener will be executed every time this action gets dispatched. For take leading, we want to start the listener the first time we see the action and then ignore any other copies of the action until this listener completes the work. So you can do that by unsubscribing as soon as the listener starts, do some work, and then resubscribe at the end. And then for the fork and join behavior, we can see that we can fork a child job, we can have it return a result, we can wait for the result in the parent and check to confirm that the child did or did not complete successfully. And same thing with waiting for with canceling the child while it was still in progress. And the listener functions themselves can check to see if they've been canceled by either having try catches around some of the cancellation aware APIs or double checking to see if listener API.signal.aborted is set to true. So based on these examples, I really do think you can do most of the stuff that sagas let you actually try and do. And then the last set of tests over here are some tests that Faber added around the current fork and child task behavior as well. I haven't looked at these in too much detail, but they work. Okay, tell you what, folks, it's actually going right about 2 hours, and my throat is getting a little bit sore at this point because I've been talking for 2 hours straight. Does anyone have any questions they would like me to try to answer before we wrap up? I think I'm going to punt on trying to actually add any more usage examples at this point. Maybe I'll come back to that one in a later attempt to stream. Let's see, questions. Seems like the philosophy behind the listener is not for the purpose of interacting with application APIs, but doing expensive operations that interact with external environments. I think that's maybe one way to look at it. Another way to put it is a lot of this is about treating Redux more as an event bus. So, like I said earlier, thunks are very imperative code. Here's a function, run the code start to end when I say it should happen, done. And the The listener middleware is more about when my app reaches some kind of a state, execute this logic. Someone was asking over in the Reactiflux Discord earlier, and I think this was a really good comparison. You can really compare this to like a use effect hook for your Redux store. So just like a use effect hook says, when this data changes, execute this callback logic. That's really what this is doing. And in this case, the thing that we're looking for is either a single given action that was dispatched or some current or state or change in the Redux state. So for example, so you could rig this up to only run one of the listeners when state.counter.value changes from 2 to 3. And then it only happens when that transition occurs because your predicate function only returns true when that's the case. So I think the best comparison here is it's like a use effect for your Redux state and actions, in essence. I've been trying to find good examples of existing Saga code that I could use as things to rewrite. And honestly, I've been struggling to come up with good examples. You can see I've been searching through GitHub trying to find various Saga use cases. Honestly, the majority of sagas that I've looked at are just doing basic data fetching. And for those, obviously, we recommend using RTK query if possible. There are some very, very complicated sagas out there. And while you could potentially replicate those with this listener middleware, that's maybe a little more advanced than I want to get into. So like trying to find that sweet spot where someone else wrote a saga that's maybe like, I don't know, 50 or 100 lines and moderately complex that I can try to port over to this middleware is actually kind of hard. Like a lot of these examples I'm looking at, I'm saying that should never have been a saga in the first place. That should have like just have been a thunk or something like that. But I do think we at least have some decent examples here in the test so far, and hopefully this helps spark a few ideas for how you might be able to use this. Question, would you be able to move the middleware init out from create store and do something like store.add middleware? No, and sort of. So the way Redux middleware work currently, the middleware chain is entirely defined statically when you create the Redux store instance. If you look at the actual Redux apply middleware function, which by the way is the single most magic part of the entire Redux source code, it takes your list of middleware once at store setup and combines them into this magically composed wrapper around the store's dispatch function. So that only happens once as you're creating the store. So normally, no, you cannot modify the list of middleware at runtime. Having said that, there are actually a couple of middleware out there I've seen that let you dynamically add and remove other Redux middleware at runtime. Like it's a middleware that you're supposed to add once at startup, and inside that middleware, it maintains its own internal list of sub middleware, and every time you add or remove one, it reconstructs that chain. So it's hypothetically technically possible to add and remove middleware at runtime. but it's really not something the Redux store was meant to do out of the box. Let's see, any other questions? Yeah, so as far as the relationship goes, once we finalize the API for the middleware, it will be added to the standard Redux Toolkit package. So just like we've got configure store, create slice, create async thunk, there will be create async or create action listener middleware or whatever we finally call it. Which, by the way, if anyone has any ideas for better names than action listener middleware, please comment in the discussion thread because we're interested. So it'll be just another export from the main RTK package. I was originally hoping that we could add this to configure store as one of the default middleware, but given that it does add about 3.5 to 4K of minified bundle size, I think at this point that's a bad idea. Also, that would, if it's part of get default middleware, it would be a lot harder to manage the TypeScript types and the setup for that as well. So most likely it'll be in the package, just another top level export, but we will not add it to the store by default. You would have to do that same, calling the create function and adding it to the store config yourself, like there is in the examples right now. So conceptually, RTK query is for data fetching. Create action listener middleware is for any other side effect type logic you might want to run in response to something in your Redux store changing in some way. All right, any other questions? Going once. Going twice. So the little lady in the back. Okay, like I said, I was hoping to get to some actual code at some point. Clearly, that didn't happen today. I've got a few ideas for future streams I might do at some point. Um, Talking about the guts of React Redux version 8 and how we did the migration over to that. There's a performance bug in reselect that someone has reported that I need to dig into at some point. I've been updating the React Redux performance benchmarks repo to try and see how React Redux version 8 is behaving. Could talk about some kind of non-code-ish things. Maybe get like Lens or somebody in here and talk about like how we manage dealing with the community and API design and all that kind of stuff. I do not intend to make streaming like a regular thing. Like, I was trying to get today's discussion up on Twitch's stream thing, and it actually forces you to say this recurs like every Friday. I do not necessarily plan to stream next Friday, for one thing, because I'll be back to my day job and I can't do that in the middle of the day. So, no plans on a set schedule for future streaming. Uh, but I would like maybe try this another 2 or 3 times and see how it goes. Um, I will try. Haha, right. I will try to give like a day's worth of heads up or notice when I think I'll do it so that people have an idea. Um, but streaming is not about to become my main activity, trust me. Um, if people do have any suggestions for improving the setup, please let me know. I was fiddling with the audio settings for like an hour yesterday, and I hope they turned out okay. Um, and if I do end up doing this very often, I may invest in some better equipment. Hopefully the video and the audio were halfway decent. All right, in that case, I'd like to thank folks for coming out. Looks like we had a decent turnout in the 25 to 30-ish range. Um, I I'm joking. Like I was kind of joking earlier. It's about like I feel sorry that you folks didn't have anything better to do with your Friday and your New Year's Eve. But I do genuinely appreciate the fact that anyone was willing to show up and listen to me talk about something that is not even necessarily of interest to most people on a New Year's Eve. That actually means a lot when you think about it. So hope you all enjoy your New Year's. Everybody, please stay safe out there. Try to enjoy yourselves, but don't get sick. And hopefully 2022 is better for all of us. Thanks, and take care.